So another application of derivatives is in the computation of related rates problems. So for related rates, we are actually differentiating our variables here with respect to time. Okay, so that is, for example, we differentiate our area with respect to time. We differentiate cost with respect to time. We differentiate, say, volume with respect to time, or any other variable with respect to time. And what is most essential here is always to make it easier, our first step here is first to establish the equation relating the variables. Okay, so that's it. And next is, after establishing the equations relating all your variables, okay, so in doing this, you really actually need your basic knowledge about relationship of variables, such as when we speak of area of a triangle, you should know that area is 1/2 base times height, or it could also be 1/2 AB sine theta. Okay, when we speak of volume, it depends what volume are you gonna use for your problem. So let's just say volume of a cylinder. Volume of a cylinder is pi r squared height, or let's say cost. So it depends on the definition of the problem, on what formula are you going to use to establish the relationship between your variables. The next thing that you need to do is to identify the unknown, or identify what is changing the variables. Okay, when you say the variables, that should be the changing. Okay, these are the changing, parang anything that is not constant, and also identify also the constant. Okay, the variables and the constant. Then third is apply concepts of differentiation. Okay, differentiation techniques. You can use all these things for any problems related to related rates. Establish the equation, identify what is changing and what is not, and apply differentiation techniques. Right? So I have prepared several problems for you so that we could check how is this going to be. So we have here an example, which is a very common type of related rates problem. A balloon is released from the ground 100 meters from the observer. So we have here our ground, and here's our, say, an observer. And looking at the balloon, 100 meters from that observer, there's a balloon that is to be released. So let's say the balloon is here, and then the balloon rises directly upward at the rate of 4 meters per second. So this is rising here. Say this variable here is variable y, and given is the rate of change of the balloon's height. It is rising at a rate of 4 meters per second. So that's dy over dt. Meters per second, that's a distance over time. Okay? So that means this is a related rate type of problem. How fast is the balloon receding from the observer 10 seconds later? How fast is the balloon receding from the observer 10 seconds later? Okay? So actually what the problem is looking for here is this variable here. How fast is this changing? Okay? So it is actually looking not for z but for dz over dt. How fast is this when the time is, or at time equals to 10 seconds. Okay? So I hope the problem is very clear to us. First procedure that I taught you earlier was establish the equation of our variables. So our variables now are here. We have z, we have y, and we have a constant here of 100. One good thing to establish this one, since the problem tells us that the balloon is rising directly upward, that means that it is rising at a 90-degree angle from the ground. So that is safe to say that. So given that idea, we can use the concept of Pythagorean theorem. Establishing Pythagorean theorem, our z squared is equal to, let's say this one is our x by the way, z squared is equal to our x squared plus y squared. That's actually the equation establishing the relationship. Second procedure is to identify what is constant and what is or are not. Right? For our problem, this is actually changing. That is why we are looking for the rate of change of it. So if the rate of change is present and is not equal to 0, therefore, it is a variable. This is a variable. How about x? X is the distance from the balloon to the observer. So if you come to think of it, will this distance change when time changes? Okay? Will the separation between the standing point of the observer and the rising point of the balloon from the ground change? It will not. It actually will not change. So that makes it a constant. So if it is a constant, you substitute it now with a constant which is 100 squared. Plus our y. Our y is actually changing. That is why we have dy dt here, the rate of change of the height of the balloon. Okay? So this is still a variable. Establishing now our equation, we can start differentiating it, which is the third procedure that I taught you earlier. So this would be now 2z, and since we are differentiating it with time, you need to put the differential dz over dt. Okay? Is equal to the derivative of the constant, which is 0, plus this is 2y dy over dt. Okay? So that would mean 0 would be cancelled. So it has no value, right? So this is dz over dt. And this would be 2y dy over dt. Canceling 2 because this is common to both. Okay? Now we can have it as what? This would be z. dz over dt is our unknown. Okay? And y is, how much is y? We don't know yet. And dy over dt is 4 meters per second. Now question, how are we going to find y and z? How are we going to find y and z? Okay? So we go back to the established relationship of the variables, which is this one. So, and this one also. Okay? So if we already have the value of y, then we can compute for z. But the question is, what is the value of y now? Okay? Remember, the balloon is rising from the ground. At time equals 0, the balloon is at the ground. And if at time is equal to 10, if the balloon is rising at this rate, how are we going to find the value of y? Is y equal to 4 meters per second times 10 seconds? Definitely, yes. Y should be equal to 40 meters. That means that after 10 seconds, y has already risen 40 meters from the ground. And if that is 40 meters and 100, the distance horizontally is constant, then we can find what is the value. Okay, so that means Z squared is equal to 100 squared, which is 10,000, plus our y squared. Y is 40, that would be 1,600. Add this one and take the square root, will give you Z equal to 20 square root of 29. Okay? So exactly at 10 seconds, this distance Z here would be 20 square root of 29 meters. And that would be, that's what we're going to use for this hanging solution here. Z now is 20 square root of 29 dz over dt, which is unknown. Y at 10 seconds is 40 meters, okay, and 4 meters per second. Computing that one would give us dz over dt equal to, so you just calculate it, 40 times 4 divided by 20 square root of 29 would give us 8 square root of 29 over 29, or that is 1.486 meters per second. That means that the balloon is receding from the observer at this rate. Okay, so that's it for this type of problem. Another example is another very common related rates problem. A 13-meter ladder is leaning against the house when its base starts to slide down. So we have here a wall. Okay, and this is, say, our ground. This one is a wall. Okay, and we have a ladder leaning against the wall. Okay, this ladder measures 13 meters based sa ating problem. Okay, this is leaning at this wall daw when the base is starting to slide away. So it's like the ladder is like this and nagsa-start siyang mag-move pa ganyan. Okay? So when nag-move siyang pa ganyan, itong dulo niya bumababa. Whereas itong kabilang dulo niya up, it's moving away. Okay? I hope you are seeing that. Okay? Halimbawa, papunta siya doon, ito naman is going down. Okay. And then, by the time the base is 12 meters from the house, the base is moving at a rate of 5 meters per second. So, at x is equal to 12 meters, say this one is x, by the time this is 12 meters, the base is moving at a rate dx over dt, which is 5 meters per second. Now, question is, how fast is the top of the ladder sliding down the wall then? So at 12 meters, this is moving away from the wall at 5 meters per second. The question is, how fast is this moving? Okay, so basically, if this is our y, what we are looking for here is dy over dt. dy over dt given these two conditions already. And we are expecting a negative dy over dt because it is going down. Okay, the value of y is decreasing as time increases. So that's a negative dy over dt. So again, this is a ground and a wall. Needless to say, that should be 90 degrees from each other. And then, first things first, we need to establish the relationship. And actually, there are certain or different problems related to this one or parang similar to this ladder problem, but depende kasi siya kung ano yung given. Since you are not seeing here angles as they're given, you're not using trigonometry to establish the relationship of the variables here. What you can only see is x, y, and this length 13 as the hypotenuse. So that means the only very clear connection of these three variables is by our Pythagorean theorem. So that would be x squared plus y squared is equal to 13 meters squared. Okay, so that's our relationship equation. And now, the second step is for us to find what is constant and what are changing. So in this problem, what is constant here is apparently the length of our ladder. Because as time goes by, the length of the ladder will not increase, neither will it decrease. So this is a constant, and our x and y values here are changing. Kasi nga, nagsaslide yung ating ladder. So the x is lengthening, okay? Whereas the y naman is shortening naman siya. Okay, decreasing ang kanyang value. Okay, so this is our equation now. And we know what are changing and what is constant. Then now we can proceed to our differentiation. Basic differentiation with respect to time. This is 2x dx over dt plus 2y dy over dt, okay, is equal to derivative of a constant is 0. We can actually cancel 2 common to both terms and transfer it now. Dx over dt, transpose the other one, negative y dy over dt. Okay. The value of x is already given. That's at 12 meters. Your dx over dt is 5 meters per second. Okay? How about the value of y? For Pythagorean theorem, if hypotenuse is constant 13 and at x is equal to 12, how much then is our y? Okay? That would be 13 squared equals 12 squared plus y squared. Computing that would give you a y of equal to 5 meters. So this would be how much? Okay? This would be negative 5 times dy over dt, which is unknown. Okay? Then dy over dt would be equal to negative 12 meters per second. So basically, when the distance for x is 12, this y here is dropping at a negative 12 meters per second rate. Okay? That's it for this ladder problem. Another example is, here's a problem. A car starting at 12 noon travels west at the speed of 30 kph. So we have a car traveling west at 30 kph. Another car is starting from the same point at 2 p.m. travels north at 45 kph. So for our diagram, we have here a car. Let's say label it as car A. Okay, this is A, and this A is traveling, it leaves 12 noon, I'll just put it here, leaves at 12 noon, and car A has a speed of 30 kph. So when we talk about speed, that is actually dA over dt. The change in distance of A over time is the speed, 30 kph. Another car, let's say car B is traveling north. Okay, this is car B and that's distance B. This is what we call, this car leaves at 2 p.m. and it has a speed or a rate of change of distance per time of 45 kph. Okay. Question here is, find how fast in kph the two cars are separating at 4 p.m. How fast are they separating at 4 p.m.? So the separation is this one. Okay. So let's just label this as C. What is being asked is, what is dc over dt at 4 p.m. Okay, so that's our question. And how are we going to approach this? First things first is establish the relationship between variables. Okay, what do we have? This one is 90 degrees, by the way. traveling west and traveling north. Okay? So basically, I think since there is no angle given here, we can use still our Pythagorean theorem so that our c squared is equal to our a squared plus b squared. Now, let's check what is constant and what are changing, if there's any. C is actually changing because we are looking for the rate of change of it. A is changing. We are given the rate of change of it, and B is also changing. Okay? All rate of change are there. So now, proceed to the differentiation. 2C dc over dt, 2A dA over dt, okay, plus 2B dB over dt. So as you can see, 2 is common to all terms, so you can cancel it directly. That leaves you with these values here. Okay, I would just like to point out that C, A, and B here are distance. They are distance values. Okay? Whereas your DC over dt, dA over dt, and dB over dt, these are velocity values. Okay? Velocity or speed values. Speed. So this one is in kilometers and this one should be in kilometers per hour. Okay, now, what's our question here? We are looking for dC over dt at 4 p.m. Since, when you look at the problem, you don't have your A, B, and C yet, we need to compute for those distances first. Okay? Remember, since this is a motion problem, it is very simple to go back to our basic motion formula, okay, to approach this problem. You should remember that always the rate times time is equal to the distance. Rate times time is equal to the distance. Rate can be expressed as the speed. So, by saying that, can we now compute the value of A, which is, from what I said earlier, that's a distance value. So, you can get that by multiplying the rate of A, which is how much? 30 kilometers per hour, to the total time A traveled from the point of origin to 4 p.m. Okay? What is that? How much is the time of A? Okay? A will travel 4 hours, starting 12 noon up to 4 p.m. So, I put that here, 4 hours. Okay? Multiplying that would give you the distance A, which is 120 kilometers. We do the same for distance B. That would be the rate or the speed of B is 45 kilometers per hour. Okay? Multiplying that to the total time B traveled. Okay, how much is that? 2 p.m. up to 4 p.m. B will only travel for 2 hours. So that's 2 hours here. Multiplying that would give us 90 kilometers. Okay. How about C? Can we compute C in the same manner we computed A and B? No, because we don't have the rate of C. So we can compute C by employing our Pythagorean theorem again. Since we now have our A as 120 kilometers, square that, plus our B, 90 kilometers, square that, that would give us C squared. Okay? Computing that one would give us 150 kilometers. C is equal to 150 kilometers. Okay? Try to absorb it first and then we go back to our differentiation part here. Okay. Now, let me just erase some portions here. So, if you want to go back to this part, you just replay the video. Okay, now, I'll just write the values here. 120 kilometers. Letter B is, distance B is 90 kilometers, and distance C is 150 kilometers. Okay? Rewriting this portion here, okay, I'll rewrite it down here. That would be C. C has a value now of 150. dc over dt is unknown. That's what we're looking for. Is equal to A, which is 120. dA over dt is again 30. Okay. Plus B is 90. Then we have dB over dt 45. Okay. So computing that one, multiplying this and adding the result, and then finally dividing everything by 150, you will now have dc over dt, which is equal to 51 kilometers per hour. So this is the rate of change of the C. This is the separation of A and B, 51 kph. And so this is not constant, guys, ha. It changes depende sa time. So at 5 p.m. this could be greater na, no, kasi medyo malayo na sila by that time. Kung nandito pa sila at 1 p.m., iba din yun. That is why the problem should specify at what point exactly are we looking for what is unknown, because it changes with time. So every addition in time, the answer will change. So there should be a specific point on which we are looking for the answer. Parang yung basis, kumbaga, dapat meron tayong specific basis for what we are looking for. Sige, that's it. Gas is escaping a spherical balloon at the rate of 4 cubic centimeter per minute. How fast is the surface area shrinking when the radius is 24 centimeters? So you just remember again the 3 rules in addressing this problem. Since may nakakita kayo ditong mga cm cube per minute, how fast is the surface area changing? So basically it tells you that you're confronted with a related rates problem again. So ano ba yung mga binigay niya sa atin? Gas is escaping at a 4 cm cube per minute. Ang iba minsan din sila familiar kung ano tong variable na to. So you just try to check the unit siguro because it could help you a lot. So since may unit tayo ditong naka cm cube per minute, basically what is given here is the change in volume per change in time natin, dV over dt. Given as 4 cm cube per minute daw siya. Okay. And tinanong, sinabi din pala dito that we have a spherical balloon. So that's very important na alam natin spherical balloon ito. Ay, wala, hindi yan. Spherical in shape. Ang tinatanong is how fast is the surface area shrinking? So let's just say that that is dSA. SA here is the surface area over dt. How fast is this shrinking when or at a radius of 24 centimeters? So very important talaga na naglalagay siya ng parameter kung saan hinahanap yung unknown. Because if you're talking about a sphere, no, in 2D lang ang nadodrawing ko dito, ayan, nagbabago-bago kasi yung rate of change niya at a specific value of R. Kaya dapat define itong condition na to. At this condition ka daw naghahanap ng unknown mo. Okay? So, ano nga yung kailangan natin gawin dito is identify natin muna ano yung mga given and which among the given are constants and our variables. So, meron tayong variable dito na dV over dt, the rate of change of volume per time, and we're looking for this variable here. And take note, the radius here is not constant. No, hindi siya nagbabago. Okay? Working equations natin dito is una, yung volume natin, the volume relations. Kasi yun yung unang binigay niya na as part of the given. And if we are having a spherical balloon here, so another important concept is you know the basic formula or at least you can derive it siguro. Okay? So for sphere, just a recall, this is 4/3 pi r cube. Yan ang magiging volume ng sphere. And syempre, mamaya, ang kailangan natin is the surface area na formula dito. Kasi yun yung kailangan mong i-differentiate. So, you also would need your surface area formula to be ultimately the one to be differentiated. So, SA ng isang sphere is 4 pi r squared. Okay? So, let's try to differentiate this muna para alam natin ano yung makukuha natin, ano yung magiging unknown sa pag-differentiate ng formula na to. Ayan. So, we will have here dSA over dt. That's what we're looking for. And then, differentiating this would be 8 pi r raised to 1 yan, di ba? Okay? And don't forget, you need to have dr over dt. Kasi r mo nga dito is a variable din. It's changing. So, there should be a rate of change for R. Ayan. So, we are looking for this one. R is given at 24 and we still lack the value of dr over dt for this final equation that we have. So, since wala tayong dr over dt, that would be taken from this equation here. Kasi nagbigay siya ng volume value. So, we will be using your volume relations as well. Now, differentiating this part muna, and dv over dt, this would be equal to 4/3, differentiating this would be 4/3, tapos times 3 yun, diba? So that would be 4 na lang, pi r squared dr over dt. So actually, mapapansin mo dito, no? Itong 4/3, 4 pi r squared, ito, is actually their surface area formula. So, related yung volume and surface area natin. Okay? And then, here we have, meron tayong dV over dt na 4 cubic centimeter per minute. And I'll just draw a line here to separate this solution. And then, this would be equal to 4 pi R na ginagamit natin as our parameter is 24. To square that one, dr over dt yung magiging unknown mo dito sa first equation na to. And your dr over dt should be, lagay ko dito ha, this is your final answer for dr over dt. Dr over dt natin is a very small number that is 5.526. So what you need to do is 4 divided by this entire thing here. So that's 5.526 times 10 raised to the negative 4. That is cm per minute. And by the way, this is a negative, this should be, by the way, itong 4, ano pala natin, 4 cm cube per minute. This should be a negative value. Edit ko konti ha. This should be negative. So, this here would be negative. Okay, bakit negative siya? Because it is escaping. Escaping siya eh. Hindi siya nadadagdag. So, basically, yung volume, lumiliit siya. No? Nag-outflow siya kumbaga. So, that should be a negative 4 cm cube per minute. So basically, if that's a negative value, your dr over dt would also be a negative value. Right? Negative din siya. Kasi negative over positive. Okay? So, having this computed already, we need to put that here. dSA over dt is our ultimate unknown for this problem is equal to 8 pi. R natin, the condition given is 24. Okay, dr over dt natin is negative 5.526 times 10 raised to negative 4. Alright, this is cm per minute. Okay, final answer for this problem, dSA over dt is a negative value also. Kasi nga nagsishrink yung ating sphere, nag-shrink siyang ganyan. So basically, ang surface area niya is also decreasing. That's why negative din to. And our final answer here is 1/3. Negative 1/3 cm squared this time per minute. Unit of area per time tayo. Alright. This is our final answer for this problem here. Okay? So, may mga ibang problems din that you can encounter na it talks about cylinder. So, for cylinder, you need to remember that the radius is constant. Diba? Kasi cylinder, hindi naman talaga nagbabago yung radius nun. Height lang ang nag-change doon. So, we have other values such as cone. No? Mga conical tanks natin. You can practice solving that one to enhance your skills sa ganito na mga type. Yung mga parang geometric type of 3D na mga geometry. So, pwede mong gamitin to. Basically, ito, ang R nito nag-change at any H. Tama? So, you'll be using ratio and proportion when you talk about conical sections naman. So, just try computing to have a better practice or better grasp of this topic. Alright? Now, let's proceed to a very famous related rates problem that most people are kind of confused of, and this is the shadow problem. All right, so we have here next problem. A light hangs 15 feet directly above a straight walkway on which a man 6 feet tall is walking. How fast is the end of the man's shadow traveling when he is walking away from the light at the rate of 3 miles per hour? And at what rate does the shadow lengthens? Alright, so I placed here two of the questions that you might probably encounter about this problem. Kasi ito yung nagkakos ng confusion sa mga estudyante. And kaya lagay natin dito para mas clear kung ano yung tinatanong niya. Okay? So, we have here a light. Ayan, meron tayong light. Lagay natin ganyan. Which is hanging daw 15 feet directly above a straight walkway. So, no, it's not directly up. Alright. Let me draw it again. Ayan. See, this is the 15 feet. So, above the walkway is a light or a lamppost 15 feet in height. And there's a man walking away from this lamppost, and this man is around 6 feet in height. So maybe this man is going to a date. 6 feet. Alright, so basically if you have a light here and a man walking there, based from our experience, especially when we were younger, now we play with the shadows. And if you realize, the shadows would be around this portion here. Right? So it will cast a shadow on this portion here. Alright, so what is being asked here is, what is the rate wherein the shadow lengthens? Okay, I'll write it here. Lengthens. And the other question is, how fast is the end of the man's shadow traveling? So we're talking about the shadow. So this one is the rate at which it lengthens, and this one the rate at which it is traveling, or the way the rate where it travels. Okay, so the other variation of this question is moving. Now, how fast is it moving? And this one is, how fast is the shadow increasing? So those are the two possible things that you could encounter. And now, given this problem here, first is we need to establish our relationship. No, relationship of the variables na are the given and the variables, everything that you can see sa figure, lahat relationship doon. Okay? So let me write two variables here kasi hindi natin alam itong length na to, right? So, you can set the entire length here or pwede mo siyang i-set na chop-chop lang siya. So, lagay ko ngayon, this would be my Y. Y is this portion here up to the position of the man. And X is this portion here. And so, if I have this, parang designation ng X and Y, we can write an equation here which is by ratio and proportion. Okay? Kasi wala namang standard talaga si related rates. That's why somehow nahihirapan yung mga estudyante kasi hindi lang nila talaga alam ano yung magiging relationship ng mga variables. So, if you are having triangle na mga drawing here, pwede mong gamitin yung ratio and proportion. You try doing that. If that works, then well and good. If hindi, you can try your Pythagorean theorem. You can try the area, basically, if that is part of the given or what is part of the unknown. So, paglaruan mo lang kung ano yung mga nasa given. Since ito, wala naman siyang sinasabing area, wala namang perimeter na sinasabi. So, ito, di mo naman din kaya gamitan ng Pythagorean. Basically, ratio and proportion ang gagamitin natin for this. So, what we have here is this side over 6. So, that's x over 6 is equal to the entire thing over this entire side here. So, that would be x plus y divided by 15. So, ganyan dapat siya. Alright? So, ano ba yung binigay niya? Di ba, isa siyang binigay na given, no? Yung 3 miles per hour. That is the rate of the man walking away from the light. The rate of the man walking away from this light. So, yung paglakad niya, pag ganon. So, basically, that's obviously our dy over dt. Okay? Ang dy over dt, again, you can check if it's a positive value or a negative value kasi di naman niya sinasabi exactly sa problem yun, no? Tinitingnan mo lang siya sa drawing. Now, if ang time mo ba nag-i-increase, itong y mo ba na to, increasing or decreasing din. So, from this point here, the man is moving forward to that direction. So, basically, yung y mo nagle-lengthen siya with time. So, ang 3 miles per hour natin is a positive given. 3 miles per hour, positive siya. Okay? So, ayan. So, given this relationship now, maybe I could identify first kung ano yung constant, ano yung variable. Ang 6 feet natin na tao, constant yan. The height of the man will never change. Right? At least for this problem. And the light of this lamppost is also a constant 15. X changes, kasi nga, naglalakad yung man, ang shadow nag-change, okay? As well as Y. Kasi nga, that's the rate of parang movement niya from the lamppost. So, X and Y are variable here. Now, setting up that equation now, perform na natin ating mga algebraic manipulation muna by cross-multiplying these things here. So, that would be 15x on this side here, and this would be 6x on that side there. Distribute natin si 6x, si 6, and this should be 6y here. Combining our 15 and 6, transposing 6 on the other side, that will leave us with 9x na lang, and this would be 6y. So, pwede mo siyang i-simplify a little further pa, but you can perform your differentiation na agad-agad. So, that will give you how much? This would be 9 dx over dt. Okay, differentiating it with time. And this would be 6 dy over dt. Okay. So, ayan. Let me move this a little on the side. As part of our given here. 3 mph. Okay. Lagay ko dito ha. So, this would be our 9 dx over dt is unknown. Okay, then 6. Then we have y here, which is 3 mph. So, that gives us a value of dx over dt, which is equal to 2 miles per hour. Okay. Now, the question is, what is this dx over dt? Ano yan? Ano yung kinocompute natin dyan? So, going back to this possible questions that we can encounter, if you are asked about the length or the how much is the shadow lengthening or how much is the shadow increasing, so it talks about this one here. Kasi, diba, if this is your light, ang shadow na makakast mo is itong X. X is the length of the shadow. I hope you are agreeing with me. Okay? So, if you are getting the change in X over time, that is dx over dt. And that is the rate in which the shadow is increasing or decreasing. Rate of shadow lengthening. Okay? That's dx over dt. So that answers the first question. This answers the second question. How much does it lengthen? So you just remember that one, ha? Kasi hindi porket shadow problem, dx over dt kagad yung isasagot mo doon. Depende yun sa tinatanong ng ating problem. How about ito? How much is the tip traveling or moving? No, ang tip niya is ito. Gaano daw to kabilis mag-change? Gaano daw to kabilis mag-move? So actually, that is with respect to the position of this lamppost here. Kasi 'di ba, kung andito yung tao, yung tip niya is nagdedepende din 'yon, no? Parang ang tip ng ano mo siguro kung nandito yung tao, nandito lang yung tip of your shadow. If the man moves further on the right, no, ba nandito na yung tao nakatayo, magmo-move na yung shadow niya, tip of the shadow dito, right? So kung andito na siya ngayon, somewhere here na yung tip of the shadow niya. So what we are asked here is actually your dx over dt plus your dy over dt. Okay? So ito yun, yung kabuuan kumbaga. Alright? Or we can write that as ganito siguro. Which is actually similar lang naman dun, no? And dx plus y. So if you can recall your basic differentiation ng mga principles, you can write this as dx over dt as dy over dt. So that gives you how much? 2 mph plus dy over dt natin na 3 mph. 5 mph ito ngayon. And this is the rate at which it travels. Rate of the tip of the shadow. Ito ha, kasi wala na tayong space. Traveling. Okay, pasintabi na kayo sa mga ano natin dyan, mga barking of the dog. Live tayo sa Pilipinas. Lahat tayo may aso. Okay, I hope you are learning still from what I'm talking about here, and I hope this will really help you move forward in the future. Yan. So, that's it for related rates.